Okay, so these are two additional examples that are available in the textbook that are a little bit different from the ones before. So you can read them from the textbook or you can watch this video. We have in this example, the first one, the line L is given by this equation right here. And lambda is a parameter and it's a real number. Show that the point D, 1, 2, minus 3 does not lie on the line. What does that mean? To not lie on the line, it means that the line doesn't go through that point. So in principle, we should not be able to find a value of the parameter lambda so that these points 1 minus lambda, 2 plus 3 lambda, and 2 lambda are ever equal to 1, 2, and minus 3. So the best thing that we can do is create a system of equations. So x is going to be 1 minus lambda, y is 2 plus 3 lambda, and z is 2 lambda because it's three-dimensional. We have 3 coordinates. And in principle, we need to show that it's not possible for this to be equal to 1 at the same time this being equal to 2 and at the same time this being equal to minus 3. So if we look at the first, for example, the first equation, 1 minus lambda equals to 1 would mean lambda equals to 0. But if we look at the z equation, we get 2 lambda equals minus 3, which means lambda equals minus 3 over 2. So we get two different values of lambda, which means D is not on the line. The reason being, it's not possible to find one parameter that makes the line go through that point. Yeah? It has to be the same value of the parameter for every single coordinate. And it's not. We got one different value for x and z. Means we don't have one. Find the vector equation of the line parallel to the line L that passes through the point D. Now we want a line that is parallel to R that passes through the point D. So we need to find a line that goes in the same direction as this line R. So we want to identify from here what is the direction vector. So I'm just going to write it in column form. 1 minus lambda, 2 plus 3 lambda, and 2 lambda, which means this should be the vector 1, 2, 0, plus lambda minus 1, 3, and 2. Of course, we get that the direction vector D is going to be the vector minus 1, 3, 2. So for my equation of the line that is parallel to this line L, I'm going to use this value of the direction line, but I'm going to use these coordinates as the point that the line goes through. So my new equation of the line for, let's say, R1, that's going to be the vector 1, 2, minus 3 plus t minus 1, 3, 2. This line is parallel to the previous line because it goes in the same direction, but it's passing through the point D. The second example is this one. We have two lines. We have the equations given in parametric form, and we need to show that the lines are skewed. Skew means that the lines are not parallel, they are not perpendicular, They are going in different directions, but they are not intersecting. So if we want to show that the lines are skewed, we need to show that it's not possible for us to find a point of intersection. So in order to find a point of intersection, we need to make sure that we are writing our equations in parametric form. So the way we're going to do that is we're going to assign one parameter to each of the lines. So let's begin by calling this line, we're going to call it L1, and then this line we're going to call it line 2 or L2. So line 1 should be R equals, or R1 equals A plus T D, while L2 is going to be R2 equals B plus lambda D. B. No. R2 equals B plus MP. So the first thing that we need to make sure is that we identify the vectors D and P, because if they are skewed, it means they're not parallel. So these two vectors should be different, but that is going to come on its own when we arrange our equations. So for L1, my equation should be x minus 1 over 3 equals to t, y plus 2 over 2 equals to t, and z over 1 equals to t. Meaning that my equation for x is going to be 3t plus 1. For y is going to be 2t minus 2. And for z is going to be t. Immediately we can see that the direction vector d in this case has coordinates 3, 2, 1. Now if we do the same for the second line, we're going to get, let's do that in a different color, x plus 3 over minus 2 should be m, y over 3 should be m, and z minus 2 over 4 should be m. So what that means is x is minus 2m plus minus 3. Y is going to be 3m, and z is going to be 4m plus 2. So for the second equation, we can identify the direction vector p is the vector minus 2, 3, 4, which means, d is different from p. And not only different, but d is not a multiple of p. So the lines are not parallel. Okay, so now with this discovery, we might just want to keep these equations, these 6 equations, and then see if we can find a value for which t and m lead to the same values at the same time. So now our job is to find the intersection. So in order to do that, once again, what we have to do is see if we can find a value of m and a value of t for which these 2 points x, y, z are the same. So we need to build the equations. 3t plus 1 has to be equal to minus 2m minus 3. 2t minus 2 equals 3m. And t equals 4m plus 2. Now we have a system of 3 equations with 2 unknowns, which means if there is a solution, we should be able to discard one of these equations because one of them should be redundant. So let's check what we get if we take, let's say, equation 1 and equation 2. What values of m and of t do we get? So let's just organize them. 3t plus 2m equals minus 4. And 2t minus 3m should equal 2. So let's multiply this equation by 3 and then this equation by 2. Yeah, if we do that, we get 9t plus 6m equals minus 12, and 4t minus 6m equals 4. Now, adding these two equations together, we get 13t equals to minus 8, which means t is equal to minus 8 over 13. So we found one value of t. Let's see if we can find the corresponding value of m. So 3t, 3 times minus 8 over 13, should be equal to minus 2m minus 3. So that is minus 24 over 13 plus 3 times 13, that's 39 over 13, equals to m negative. So 39 minus 24, that is 15 over 13 equals minus 2m, which means m has to be 15 over minus 26. Okay, so we got a value of t, we got a value of m. Let's see if it's true for the third equation. The third equation is t equals 4 times m minus 15 over 26 plus 2. If this is true, then the value of t that we should get should be minus 8 over 13. So I'm just going to calculate that using my calculator. 4 times minus 15 divided by 26 and then add plus 2. The answer is t is minus 4 over 13. So basically we got t1, but we also got t2 from the third equation. And so since t1 is different from t3, sorry, I called it t2, then what this means is that there aren't any values of t and m. So what that means is the lines are not intersecting. So there are not any values of t and m for which the lines L1 and L2 intersect. Therefore, the lines are skewed. Okay, now for our final example. Determine the values of A and B so that the following lines L1 and L2 and L3 are concurrent. Concurrent is another word for intersecting. So what we should be looking at is my line L1 should be doing this, my line L2 should be doing this, and my line L3 should be doing this. And there should clearly be a point here of intersection of all three lines. So there's a point of intersection for all of them. How do we do that? Well, similar to the previous example, we want to determine what values of the parameters make these lines intersect. So we are just going to write these equations in terms of the parameters. And we get, let's start with L1. X minus 5 over minus 4 equals t. Let's use Greek letters for this because it's better to be consistent. Equals to mu. So x is going to be minus 4 mu plus 5. Y plus 1 over 3 is equal to mu as well. Therefore, y is going to be 3 mu minus 1. And z minus 1 over 2 is also equal to mu. That means z is 2 mu plus 1. So now I have my three equations, x, y, and z, for L1. Now let's do L2. For L2, we have 3 minus x is equal to alpha. And so that means x is equal to, so that means x is equal to 3 minus alpha. Then 6 minus y over 2 equals alpha, means y is 2 alpha minus 2 alpha plus 6. And finally, z plus 1 over 2 equals 2 alpha, means z equals 2 alpha minus 1. Now let's do the same for L3. That is x minus a or equals beta. That means x is equal to beta plus a. Oh, let's write it here instead. Equals beta plus a. Now y minus 8 over b is equal to beta. That means y is b beta plus 8. And finally, z plus 5 over 4 equals beta. That means z is equal to 4 beta minus 5. So now we got my three equations. Here, my three equations here, and over there. Now the thing is, for these lines to be concurrent, these x, y, and z values, they all should be equal to each other. So what we can do is try to solve one system of equations for line 1 and line 2, and then force that solution into line 3. So let's do that. Okay, so let's see if we can solve for line 1 and line 2. So in this case, 3 minus alpha should be equal to minus 4 mu plus 5, and also minus 2 alpha plus 6 should be equal to 3 mu minus 1. Let's just organize them so that they look nice. So 4 mu minus alpha equals 2 and minus 3 mu minus 2 alpha equals minus 7. Now I can multiply the first equation by minus 2, and that would be minus 8 mu plus 2 alpha, and that should be equal to minus 4, and minus 3 mu minus 2 alpha equals minus 7. We can eliminate alpha if we add these two equations together, and we get minus 11 mu equals minus 11. So mu is equal to 1. Now with that, we can find alpha. Alpha should be 3 plus 4 times 1 minus 5. So alpha should be 3 plus 4, 7, minus 5, 2. Alpha is 2, mu is 1. Now let's check, just to check if this works for the third equation, which would be 2 alpha minus 1 equals 2 mu plus 1. So if this works, then if I substitute mu, I should get alpha equals to 2. So 2, or these two things should be equal. 2 times 2 minus 1, is that equal to 2 times 1 plus 1? So 2 times 2 is 4, minus 1 is 3. And 2 times 1 is 2, plus 1 is 3. 3 equals to 3. It works. So we know that the intersection of line 1 and line 2 is going to happen when mu is 1 and when alpha is 2. Now, for the third equation of the third line to also go through that point, we need to force that point onto the third equation. We need to substitute the values of x, y, and z. So let's calculate the point of intersection. The point of intersection of line 1 and line 2 should be the point x equals to 3 minus 2, 1, y equals minus 2 times 2 plus 6, so that is minus 4 plus 6, 2, and z should be 2 times 2 minus 1, so that is 3. So the point of intersection is the point 1, 2, 3. And we need to force that point onto the third equation. So now we're going to substitute 1, 2, 3 onto here. And we get 1 should be beta plus alpha, beta plus a. 2 should be b beta plus 8. And 3 should be 4 beta minus 5. So from here, from the third equation, we can find the value of the parameter for which the z coordinate is 3. So we solve for beta there. So 3 plus 5 divided by 4 is beta. That means beta is 2. And now we get a system of equations. Or actually, we can also find from 1, we can also find the value of a there. 1 should be 2 plus a. That means a is minus 1. And also, we can use equation 2 to calculate b. So b should be 2 minus 8 divided by beta, which is 2. So that is minus 6 divided by 2 is minus 3. b is minus 3. So there you go. We found the values of A and B so that the three lines are concurrent. That means so that the three lines are intersecting at the same point.